So today we're going to take a look at hyperbolic functions. So these feature in Book 2 of the Core Pure Mathematics official Edexcel textbooks. And you can find some questions for these on the old Edexcel Further Maths Spec, so they were on FP3. And I've featured one of those questions later on in the video, so you can see that as we work through. So I started off with a couple of questions from the textbook, so we'll work through them together. So I've not picked anything in particular, just a mix of questions that involves differentiation, integration, just solving general hyperbolic equations. So let's have a look. So the first question involves an integration, and this is from exercise 6e, question 24. So let's get a pen. So we've got to integrate 1 over the square root of x squared minus 2x plus 2 between 3 and 1, giving our answer as a single natural logarithm. So 8 marks for this. Well, when you see an integration of this format, so it's 1 over the square root, so between 3 and 1. So if you ever see an integration like this where it's 1 over the square root of a quadratic, so x squared minus 2x plus 2. So like I said, if you see it where it's this form, 1 over the square root of a quadratic, straight away you should be thinking about trying to complete the square on this and seeing what happens. So let's complete the square on x squared minus 2x plus 2. Okay, well, if we complete the square on that, well, that'd be, we halve this middle term here, so that'd be x minus 1. We square that, we'd square this and take the negative of it, so minus 1 squared would be 1, but we want minus 1, plus the 2, that'd give me plus 1. Okay, so when we complete the square, we get x minus 1 all squared plus 1. Now, because it's of this format here, we can rewrite this integral. So this will be the integral between 3 and 1 of 1 over. So it's the square root now, the square root of x minus 1 squared plus 1. Okay. Now, you've got to use your final book at this point, unless you've kind of just got them memorised by heart. You've done enough of these questions, or memorised by memory. I don't even know what I'm going on about right now. But as long as you've got it memorised, basically, that's all that matters. Or you can use the formula book. So what this would be now, this would be x squared plus a squared. Okay. So because it's of that format, we need to use, inverse hyperbolic sine. So shine x over a. So x over a. Okay. So it's going to be of that format. So using that with ours, that'll be my x, that's going to be my a. So we'd write that as r shine of x minus 1, and this is between the limits now, my 3 and my 1. Okay, 3 and 1. Okay, so imagine we put these limits in. So that'd be inverse hyperbolic sine of 3 minus 1, so that'd be inverse hyperbolic sine of 2 minus, so it'd be 1 minus 1, so it'd be inverse hyperbolic sine of 0, which would just be 0 anyway. So we'll write it down, just so it's clear what's happening, but it will just be 0 anyway. So we just get left with inverse hyperbolic sine of 2. Okay. So now, again, we need to use from the formula book the formula that we can use for inverse hyperbolic sine of a value. So this would be ln of x plus the square root of x squared plus 1. Okay. Well, our value is 2. So wherever we've got an x, we just need to replace it with 2. So for us, ours will be inverse hyperbolic sine of 2. So that'll be ln. My set brackets are pretty bad. 2 plus the square root of 2 squared, which is 4, plus 1. So 4 plus 1, 2 plus root 5 there. Okay. And that's it. That's my final answer. So ln 2 plus root 5. Okay. So we've given our answer as a single natural logarithm. Okay. So 8 marks there for that. Okay. So I just had to answer the door there. I don't know if you could hear it on the video, but let's carry on. So we've got this question here where we're solving this hyperbolic equation here where we've got 9 cos x minus 5 hyperbolic sine x is equal to 15. So 6 marks for this. These questions are pretty standard. You've just got to remember that we when we're solving these equations, we want to get the hyperbolic functions in their exponential form. So if I rewrite this now, this 9, we're in red, I don't want to be in red. Let's just erase that. Change it back to white. So remember, cosh is e to the x plus e to the minus x all over 2. And then hyperbolic sine is e to the x minus e to the minus x. So e to the x minus e to the minus x, okay, over 2. So using that now, we need to do 9 lots of cosh x. So e to the x plus e to the minus x over 2 minus 5 lots of hyperbolic sine. So e to the x minus e to the minus x over 2. And we know all of this is equal to 15, okay? So at this point now, we just need to manipulate this. Well, what I could do here now is times through by 2, okay? It'll get rid of this denominator of 2. So if you think about it, this is technically 9 over 2, and this is minus 5 over 2. So if I times through by 2, we'll just get it in terms of integers rather than a ratio like this. So this will be 9e to the x. So I'm going to times through by 2 and then expand as well. So 9e to the x plus 9e to the minus x minus 5e to the x plus, so minus 5 times minus e to the minus x will be positive, so just be very careful there. It's very easy to make a mistake. Plus 5e to the minus x. And obviously we've got to times both sides by 2, so 15 times by 2 will be 30. Okay. And at this stage now, we just need to simplify. So 9e to the x minus 5e to the x, so that will give me 4e to the x. And then I've got 9e to the minus x plus 5e to the minus x, so that will be 14e to the minus x. And we've got a 30 here, so we're going to take that across to this side. So minus 30 is equal to 0. Okay, so let's just double check we haven't made any mistakes. Yeah, that looks good. Now remember, this e to the minus x is the same as 14 over e to the x. Now, rather than try and solve it in this format, I'm going to multiply through by e to the x. So I times everything by e to the x. Well, times this by e to the x, I'll just give me 14. So that'll be plus 14 there. 4e to the x times by e to the x. Well, that'll just be adding another x to the power. So that'll be 4e. So the 2x. And then finally, minus 30 times e to the x will be minus 30e to the x. Okay. Now at this stage, this is actually a quadratic that we can solve for. So this is still equal to 0. So if we factorise this now, well, in fact, before we factorise it actually, because everything is a multiple of 2, we can divide by 2. Now you don't have to divide by 2, but it just makes life a little bit easier. So before I do that, that'd be 2e to the 2x. I'll put the minus 15 first. Plus 7 is equal to 0. Okay. And now let's factorise this. So this will be 2e to the x. I'll just put minus something, and then I'll just put an e to the x minus something. Now they both might be minus. In fact, they're both going to have to be minus in this case, because that's a negative term in the middle, and this is positive. So which way around will this go? So this will be 2e to the x. So that'll be minus 1, and that will be minus 7. Okay, because I'll give you minus 14, minus another 1, give you minus 15. Perfect. So we've got 2e to the x minus 1 times e to the x minus 7 is equal to 0. So now we just need to solve from here. So what that means is that e to the x is equal, well, if you rearrange this, this would be 2e to the x is equal to 1, divide by 2 would be e to the x equal to a half. Or we could have e to the x is equal to 7. But remember, we haven't solved it here. We need to take the logs of both sides. So x will be equal to ln of a half, or x could be equal to ln 7. Okay, and then that's both my solutions for this this equation here. So x is equal to ln a half, or x is equal to ln 7. So 6 marks for that. That's a very standard question though. So you've just got to write your hyperbolic functions here in terms of their exponential form, and then just manipulate and solve from there. Okay. So hopefully no issues with that one. Let's move on to the next one. So this is a question involving hyperbolic differentiation. So we're given this function here, y is equal to a cosh nx plus b hyperbolic sine nx. And a and b are just constants. So we've got to prove that the second derivative is equal to n squared y. So 4 marks for this. Well, we need a second derivative, so before we can get a second one, we're clearly going to have to differentiate at least one time. So let's differentiate this. So dy by dx. Well, we've got a cosh nx. So if I differentiate a cosh nx, well, the differential of cosh is hyperbolic sine, shine. So I'm going to have my a at the front, but remember, because this is cosh nx and we're differentiating this with respect to x, then my n is going to come to the front as well. If that was like 3x, for example, it would be 3a, for example. So this will be the same now as an hyperbolic sine of nx. Okay, so that's the cosh differentiated. Let's do the same with hyperbolic sine. So again, there's going to be an n that comes to the front, so that'll be plus bn. And because it's hyperbolic sine, when you differentiate that, you get cosh. So that'll be cosh nx. And that's the first differential there. So my first derivative is an hyperbolic sine nx plus bn cosh nx. But we need to differentiate this once more. We need the second derivative. So second derivative. So again, the differential of hyperbolic sine is cosh. And because we've got this nx still at the end of it, it's going to come to the front again as an n squared. So this will be a n squared, like so, and it'll be cosh nx. Same again with this cosh here. When you differentiate this, the n's going to come to the front again, so it'll be bn squared in this case, and it'll be hyperbolic sine. Okay, so we're nearly there now. We need the second derivative to be equal to n squared y. N squared y. Okay, so we've got an squared cosh nx plus bn squared hyperbolic sine nx. Well, we're nearly there, but it's obviously it's not quite how they want it. Now, don't forget our y is a cosh nx plus plus b lots of hyperbolic sine nx. So I've got an n squared here. I've got an n squared here. But let's see what happens when we factorise that out, right? So this will be equal to n squared a cosh nx plus b shine nx. Okay. Well, this now is actually just my y from the beginning. A cosh nx plus b shine nx. Okay. So this is just equal now to n squared y as required, because we have the y in the first line of the question. Okay, so 4 marks. That's quite a nice differentiation question. That probably something quite early on, or as the first part of a hyperbolic functions question. Okay, so hopefully that makes sense. If there's anything that you want to clear about with that, just be sure to leave a comment. But yeah, let's move on to the next one. So this time, another solving question, but this one's a little bit different. Rather than it just being equal to a constant, a number, we've got this e to the x as well on the other side. So remember, we've got to write this in terms of the exponentials. So I'm going to write this now straight away as 18 lots of e to the x plus e to the minus x over 2 plus 14 lots of shine. So that'll be e to the x minus e to the minus x over 2. And this is equal to 11 plus e to the x. Okay. Well, if I've got 18 over 2 and 14 over 2, these will just divide. 18 over 2 is 9. So that's 9 lots of this. And this will be 7 lots of this. And this is equal to 11 plus e to the x. Okay. Well, now I can just expand these terms and then just start rearranging and get it in terms of make it equal to 0, and then we can just solve it by factorising. So this will be 9e to the x plus 9e to the minus x plus 7e to the x minus 7e to the minus x. Still equal to 11 plus e to the x. Oops. 11 plus e to the x. Okay. So now, what I'm going to do is I'm going to simplify this. So I've got 9e to the x plus 7e to the x. So that'd be 16e to the x. But we've got an e to the x here. Now we want this to be equal to 0, so I'm going to take this off this side. Well, that'd be 16 minus e to the x. So that'll be 15e to the x. Okay. I've also got my 9e to the minus x minus 7e to the minus x. So that'll give me 2e to the minus x. So plus 2e to the minus x. And then we've just got 11 here. Now I want this side to be equal to 0, so I'm going to subtract 11 off both sides. So that's minus 11. And that's equal to 0. Okay. Remember again, this is 2e to the minus x, which is the same as 2 over e to the x. Now we don't want to try and solve it here. We need to simplify this for ourselves, so we're going to multiply through by e to the x. So that would be 15e to the 2x. That 2e to the minus x would just give you 2, and then that would be minus 11e to the x. Okay. And we can make this equal to 0. So now we just need to factorize here. So, because it's 15e to 2x, it's either going to be 15 and 1 or 5 and 3. So this you might just have to play around with. But seeing as I've already worked it out, what it does work out to be is 5e to the x minus something, and that'll be 3e to the x minus something. Okay. Well, what are these somethings? Well, I need it to give me plus 2, and because it's minus 11 in the middle again, this is going to have to be minus 2 and minus 1. It's just which way around it goes. So it'll be minus 2 there and your minus 1 there. Okay, so solving both of these now being equal to 0, the first one would be e to the x is equal to 2 over 5. And then my next one would be e to the x is equal to 1 over 3. But these aren't our solutions. We need to take logs of both sides. And it wants it in the form ln of a, so take the natural logarithm. So this will be ln 2 over 5. And so that's x is equal. And then it'll also be x equals ln of a third. Okay. And there we go. So a is rational because obviously it's a ratio like this. But there we go, so 5 marks for that. A little bit different because it's not just equal to a number. We've got the e to the x on this side as well. But nothing too tricky. But I thought I'd throw it in there just to show that it can sometimes be a little bit different. Okay? But still pretty standard. And then finally, let's move on to the last question here. So we have to prove that the inverse of hyperbolic tan of x is equal to a half ln 1 plus x over 1 minus x. So let's start by defining this. So let y be equal to inverse hyperbolic tan of x. Okay. Now, what I'm going to have to do is rearrange this to be in terms of x. So if I want this to be in terms of x, I'm going to have to times both sides by hyperbolic tan. So therefore, x will be equal to hyperbolic tan of y. Okay, so I've just times both sides here by hyperbolic tan. So obviously, if you've got the inverse, times it by tan, hyperbolic tan, you'll just get x. So x is equal to hyperbolic tan of y. Well, using the exponential definition now, this is equal to e to the 2y minus 1 over e to the 2y plus 1. Okay. Well, now I'm going to multiply through by e to the 2y plus 1. So remember, this is x equals. So x is equal to this. So this would be x times e to the 2y plus 1 is equal to e to the 2y minus 1. Okay. Now, because our final answer ends with this being in terms of an actual logarithm, I need to rearrange this now to be in terms of e to the 2y, right? Because then we're going to take logs. So what I'm looking to now is rearrange in terms of e to the 2y. So I'm going to multiply this bracket out here. So this will be x e to the 2y plus x is equal to e to the 2y minus 1. Okay. Now, it doesn't matter which way you rearrange this for, but I'm going to take my x e to 2y over onto this side. It just makes it a little bit easier to it, but it wouldn't matter if you did it on, if you took the e to 2y onto this side. That would not matter either. But just to make my life a little bit easier, I'm going to do it that way. So this will be x plus 1 on this side. So x plus 1 is going to be equal now to e to 2y minus x e to the 2y. Okay. Well, now I've got an e to the 2y on this side here, so I can factorize that out. So this is x plus 1 is equal to e to the 2y times 1 minus x. Okay. Now I can divide through by 1 minus x, and I've got it in terms of e to the 2y then, which is what we wanted. We wanted to get it in terms of e to the 2y, so we can then take the logs and get it into this format. So e to the 2y is equal to, I write as 1 plus x, just like they've got it, over 1 minus x. So now, take logs of both sides, so this would be, do it up here, this will be 2y is equal to ln 1 plus x over 1 minus x. Okay, so to get it in terms of y, we just divide by 2, so y is equal to a half ln 1 plus x over 1 minus x. And remember, like we defined at the beginning, y is equal to the inverse of hyperbolic tan. So the inverse of hyperbolic tan of x is equal to a half ln 1 plus x over 1 minus x. Okay. Now, before we finish this question, let's just make a little comment on this here. So the modulus of x being less than 1. So the absolute of x is less than 1. Now, the reason this is important, and we have to make a comment on this, so we need to say x less than 1, because let's consider what would happen if it wasn't. If the absolute of x was bigger than 1, well, what we'd actually get then is that this value here, half ln 1 plus x over 1 minus x, wouldn't have a definition, it wouldn't be defined, because, so let's write over here, ln of 1 plus x over 1 minus x is not defined. As 1 plus x over 1 minus x will be at least or smaller than 0. Okay, remember we can't define ln for that value. So basically you get an error on your calculator. So this condition has to hold here. Okay, so you just need to make that little comment as well, just at the very end. Okay, and that's it. So that's it for this video. Hopefully it's helped. So just a mix of integration, differentiation, solving, and then just proving the inverse form here for hyperbolic tan. So I hope it's helped. Be sure to leave a comment, subscribe, all that good stuff. Yeah.